Okay, good morning. My name's Elaine Newton. I work for the National Institute of Standards and Technology, which is an agency under the Department of Commerce. I didn't get the clicker.
I was just testing you.
Okay. So NIST is a big place with lots of scientists and engineers. I'm from the Information Technology Lab. You may have heard of NIST because of ITL. You may have heard of it because we have Nobel Prize winners in chemistry, physics, time. We keep the official time. I'm from the part of NIST that deals with cybersecurity, biometrics, networking, and started there about 10.5 years ago in the biometrics group, moved to the computer security division, mostly because my interests have been in biometrics, security, and privacy topics. And went from there to the identity management side and still do that in the biometrics field. And then I also work a lot on standards issues for our lab because we have about 100 different people working in open standards. You name the topic, we probably have somebody working on it. So let me just get a sense. I sort of have a choose your own adventure kind of presentation. So how many people in here are in the biometrics industry? Okay. Any of you say it's a significant part of your current or a past job, other than the biometrics industry people? All right, so what I'm going to do is go over an introduction to the technology and give you some history and testing, and then tell you where we're at with security today. So apologies to the biometrics experts because this will be a little bit 101 for you. First, with biometrics, you can't recognize anybody unless you've encountered them before. So the first part of a biometrics process is enrollment. This is a critical stage because you have to make some decisions about where you store the data, which has implications for security and privacy. You also want to make sure you're doing this securely and not enrolling somebody with a false identity. You also want to make sure that if you have a big rollout, that the devices are available to the users, that that's not going to create a big cost for you. So for example, the idea behind the FIDO use case is a big shift because users now have biometric sensors on their phones a lot of times, so you can already have a leg up on where the data is stored, that the people have sensors to enroll and then to subsequently authenticate. The next process is the capture for recognition. And obviously security is a big issue here, so is usability. Users a lot of times will have issues with fingerprint recognition or other modalities, not to pick on fingerprint. And sometimes they're demographics issues, sometimes it's an issue across all people. But these are some topics to figure out when you're doing a big rollout. Next is you want to compare what you captured at recognition, the subsequent recognition point, to enrollment. And that'll produce a number. So this is the big difference in biometrics between other authentication factors. When you look at passwords or crypto keys, you get a match, no match. That's not true in biometrics. You get a similarity score. And from that score, you're operating at a certain point, and you have to make a decision. And from that point, you decide you have a match or a no match, and that may be true or false. So to get into explaining what terms mean like false match rate and false reject rate, false accept rate, we'll explain all the different permutations. If you're doing a test in biometrics of people who look, of people who are supposed to be matches, true matches, hopefully their similarity scores are going to be higher than people who are not supposed to match. But in biometrics, there's always an overlap in those scores. So figuring out a threshold for where you want to operate at is a key part of rolling out a biometric system. So that line will give you more false matches or less false matches, and there's always a trade-off with your false non-matches. Where you see the line now is an equal error rate. In other words, if you divide that space in half, it tells you something about the system that you can characterize quickly to say, this is where the false matches and false non-matches are equal. This statistic you hear sometimes just to be able to quickly summarize how a system works. It's not necessarily where you want to operate at. Frequently, you'll also hear false accept rate. That is a term based on the application itself. So, for example, if you're doing a watch list application, you wouldn't call it a false accept rate when you have a false match rate. But with something like a mobile application where people want positive access to a system, a false accept rate and false match rate are roughly equivalent. Same with false non-match rate. Frequently you'll hear that called false reject rate, but that's, again, dependent on the application. Authentication or verification in biometrics is referring to taking a look at one-to-one matching as opposed to identification, where you're looking at your entire database and trying to figure out who a person is. Has that person been encountered by the system before? So we'll come back to this kind of slide. And just want to mention at this point that there are lots of points in a biometric system where it could be attacked. And we'll go over this a little later. So now we're going to shift to testing and standards at NIST, which is the lion's share of biometric testing around the world. Most of this testing, I should say probably all the testing, has to do with the matching performance. So it started, the work at NIST in biometrics started in 1969 when the FBI asked NIST to help develop the technology for fingerprint matching. And fast forward to the 80s, the first standard was published by NIST as accredited as a standards developer because the local law enforcement agencies and the FBI couldn't agree on what data format to use to swap data. And NIST had to help mediate by creating a standard in '86 with the community, and they've been revising it ever since. Fast forward to the 90s, if you're in face recognition, you might know Jonathan Phillips. He really was the pioneer to get NIST and the Army Research Lab where he was at first, and DARPA to put a lot of funding, researchers in the area of face recognition, and then again in iris recognition. All this work, it was pioneering work, but really after September 11th, that started a whole new interest and levels of funding for NIST to do major tests. So we have data that a lot of folks can't get access to. We have the sheer volume of it from DHS, Department of State, Department of Defense. That has allowed NIST to do these major tests in fingerprint, face, and iris recognition. If you want to see specific testing, you can go to fingerprint.nist.gov, face, or iris.nist.gov, and see the evaluations that have been performed. There's also an ongoing fingerprint test, whereas the other tests are usually held at a certain point in time, and fingerprints are tested continuously because of the PIV cards and being able to always refresh our information on the error rates there. In addition to the matching performance, NIST has been doing a lot of testing in other factors that affect performance. So if you have a fingerprint or a face or an iris received, before you go through all the computational complexity of looking for a match, you're going to want to know if it's a good sample, and that's called a quality metric. So there's been testing in quality metrics. There's also testing in compression effects, rolled versus flat fingerprints, 3D versus 2D, all these different factors that could affect performance. NIST has done a lot of testing in that. And this is a graph for you just to take a look at the history. So a lot of this testing has had I would say, unplanned effect of bringing down the error rates in these modalities. So over time, if you look, this is an example with face. The error rates in face recognition have gone down substantially from 93 to 2010. And you can see the same thing in fingerprint, you can see the same thing in iris, because what I think has happened is you have testing by NIST, a third-party tester, that has that has mass amounts of data and then publishes the results online. And that has created a good way for people to know where the state of the art is. It creates competition. And over time, you see these error rates dropping in all the modalities we're testing. So some of the principles that have come out of doing this kind of testing is, again, third-party testing is a major benefit for obvious reasons that if you're testing your own products, you have a clash of interests. The data is also sequestered. You get a sample of data before you submit an SDK, but in general, the lion's share of the data is sequestered so that the testing cannot be gamed. The results are also published, and the method for testing is published, so you can decide if the work applies to your application. Okay, so we're going to shift to the security side of biometrics. So with cell phones getting lots of different gadgets, for example, with cameras, there's a big shift in what's available to users. So when cameras started being available on smartphones, you started seeing all kinds of uses of cameras that people hadn't anticipated, like video of every news event, like kids falling in a zoo pit, gorilla pits at the zoo, or being able to get video from Abu Ghraib, or you name it. There's hardly a story that doesn't have some kind of camera, some video or pictures from the event. Well, in a similar way, there's a shift in the last year in biometric sensors. So a couple of people have noted in the biometric industry that there's a major shift in this past year of the availability of fingerprint sensors in particular on smartphones. And by 2020, an Acuity report predicts that 3 billion phones sold per year will have biometric sensors as a standard tool on a phone. So all the testing and standards that you heard me talk about that have been developed so far are really built around the use case of law enforcement and immigration. And the use case in FIDO, like for online transactions, for healthcare, banking, whatever use for positive authentication for consumers, have very different features. So in enrollment in law enforcement, you may be literally manhandled to get your fingerprints, or at least there's an attendant there, like at the airport. Whereas you don't have that situation with mobile and online transactions. Also with authentication, you're not going to have somebody, an attendant there to make sure that the person's putting their finger on correctly, dealing with errors, seeing if there's a spoof, like a mold on the finger, or holding up an iPad in front of the sensor with video of the wrong person's face. And successful recognition in law enforcement and immigration asks the question, has this person been encountered before? Identification question, as opposed to, is this person actually who they claim to be? Do I trust that this sample came from that person? So one of the big things that we are concerned about when it comes to the security of biometrics is presentation attacks, or spoofs. And you've probably heard liveness detection or artefact detection. These are types of presentation attack detection. In the case of FIDO, you're not going to be concerned about all the types of possible spoofs, but in particular, you'd be concerned about fake fingerprints, videos, or pictures being held up in front of a sensor. You might also be concerned that someone will just try to randomly try their own fingerprint or their own face to see if the recognition is close enough. And presentation attack detection is just one type of vulnerability in a biometric system. And this graph shows you all the different types of vulnerabilities that, in a way, that someone could mount an attack on a biometric system. So even though we've known about these types of attacks, there really hasn't been that much work on them in the past. And there's now a new market there. We keep getting questions when we open up 860, NIST Special Pub 800-63. for example, of why don't we include biometrics more? Why don't we say more about how to implement them? There's really not much out there, including in our own documents, and outside of that, there's not a guidance document or a standard that says this is how to do this well, securely, privately for positive authentication. We recognized this and we decided to start trying to get a leg up in 2010 and started working in this international standards community to create data formats for swapping data about presentation attacks and also doing testing on products and services. That's actually coming to, not a close, but it's very mature, and the first part of that work is published and freely available, that it describes the problem of presentation attack detection, and the data formats and the testing standard are going to be published, I'd say probably a year and a half. The number is 3107-1, -2, and -3. And we also joined the FIDO Alliance last year in the Biometrics group. We are actively participating in trying to deal with the security side of biometrics in that group. So along similar lines, we've decided through a workshop that we held last January that we're going to be looking at quantifying biometric security and trying to figure out how we can compare one system versus another, one implementation of biometrics versus crypto keys, and one versus passwords, for example. This is what we're calling the problem, SOFA, the strength of function for authenticators. And what we're trying to ask is, how can we compare the strength of biometric authentication to other types of authentication? So I showed this slide earlier where we looked at different attacks on a biometric system. And we have, something must have let out. Okay. What we did when we first started this work is to look at all the different attacks on a biometric system and saw that when we go through all 11 points, there are a lot of commonalities. So there's a lot of things that are dealt with through encryption, mutual authentication, limiting unsuccessful attempts. And there are 2-3 things that are not general in cybersecurity that are specific to biometrics. In particular is the false match rate, when somebody should not be matched and they're let in. So that's dependent on the matching performance of the algorithm itself and how distinctive the biometric pattern is. And also the presentation attack detection error rate, which is the probability of a spoof getting through. So we decided to start thinking about how we compare biometric system attacks to password or crypto key attacks. We want to try to quantify it. So we're looking at controls that are not something that are going to be quantifiable or easily quantifiable, and say you need to do certain things, but across any authentication system. But there are things that are inherent to biometrics that are quantifiable that we can try to use to compare passwords versus biometrics. And we divide that into 2 categories: zero information attacks or target attacks. So in a zero information attack, we assume the attacker doesn't know anything about the particular user they're trying to attack. They are just trying to get into the system under John Smith and without knowing anything about what their data looks like. So they would have to work against the false match rate of a particular system and create something that passes any spoof detection. So our hypothesis is that if you take the false match rate and the pad error rate, you can combine those to create something that is similar to passwords entropy. We also want to consider the effort to mount these different types of attacks. So in a zero information attack with a password, you just have to try the permutations, all the permutations of a password. With biometrics, you have to create the spoof, you have to have access to the sensor, you have to go through the computational complexity of a biometric algorithm, which is going to be different than a password or a PIN. In a targeted attack for passwords, a hacker would have possibly access to where someone wrote down their password, they could do shoulder surfing. In a targeted attack for biometrics, you know who you're trying to attack, and the biometric data is not secret, so the effort there is lighter to retrieve the biometric, but you still have to create the artifact. So at this moment, at this stage, we know we want to incorporate effort. We have some idea of how we might quantify it, but we're really not there yet. We have an idea that we want to somehow incorporate the time, knowledge, and resources to mount each type of attack. We also want to incorporate consequences. So if you were to kidnap or kill a person in order to get their fingerprint on a sensor, those are consequences that we want to factor into effort, because that's not going to be a common attack. Okay, to sum up, we have the strength of function authentication proportional to the effort over the product of the false match rate and the presentation attack detection error rate. That's in the case of zero information attack. In the case of a targeted attack, that false match rate essentially goes away, because what you're relying on then is just the true match rate, or 1 minus the false non-match rate of the biometric system. Compare that to what we would call the strength of authentication for a password or a crypto key, where you would have the effort times the number of permutations for the key. So entropy is the log base 2 of all those permutations, n to the L. Okay, on this particular project, we are looking for people to let us know their thoughts on our approach. We haven't put out a draft. We gave most of these slides at a conference at IBPC at NIST, and the slides are available online. I'm sure these slides will be available online too. But we will produce a draft, and we're happy to hear even before the draft. We have an email address, sofa@nist.gov, so you can let us know if you think we're on a good track, bad track, and we can stay in touch as we put out drafts. We also, in addition to that equation that I put up, we want to go over the types of practices that need to be done outside of biometrics. So for a biometric system, what are the cyber hygiene things that need to be taken care of? Related to this is the draft on 800-63. So the NIST special pub that goes over entity authentication is being revised. You may have seen sort of a preview draft that was posted at that URL. And we're working this problem in both of these spaces, as well as in the FIDO Alliance group. And we're trying to make sure that they're very similar approaches. They're not going to be exactly the same, because FIDO, for example, is a profile for a specific use case, whereas 863 is trying to answer questions for a lot of different scenarios. And some of the other standards are even higher level or broader than that. So let me just touch on, because I didn't expect to have time to go over all of this, but one of the things that we're talking about in the FIDO Alliance is how do we take what we've done with presentation attack detection and actually create a testing plan for products and services. So if somebody is selling a pad or a biometric system and they say we do presentation attack detection, if you're a relying party, how do you know that that system is reliable and that it's doing what it says it's doing? So we're starting to think about how to do this, and we're talking about levels of risk, which level of risk FIDO is in. If they need levels of risk, we still need to discuss. We're also looking at what's needed for false match rate across known modalities, fingerprint, face, iris, voice, but we don't want to say you can't use any other modality. But this approach really requires some information about how to attack each modality. We also want to do testing according to spoofs attacks that are known versus unknown, because it makes a big difference. When we've seen testing done by Stephanie Shuckers at Clarkson University, they've done attacks. They've done attacks on with known spoofs and unknown spoofs, and there's a big difference in the performance. So we've proposed something to, I'll just fast forward to here. We've proposed something to look at the different levels of risk for each of these modalities, and proposed what's required to pass and not pass. And this is work that I'm doing with Stephanie Shuckers. We've proposed it in the group of the Biometrics Assurance subgroup, and I hope this is an encouragement to people in the audience who care about this kind of work to come join the discussion there, or join the discussion in ISO IC JTC1 SC37. If you want to know about any of that alphabet soup, please feel free to talk to me afterwards, and I can tell you how to get involved. It's important if whether you're a relying party or a company that's building these products, to get involved in the standards. Just to wrap up, there's some references for the SOFA work here, and it's not just me, there's a team behind it. And the work on pad air rates, those are the references. That's done with Stephanie. And any questions?
I'm curious, there's always sort of people inventing new biometrics. And so for example, we've seen on Windows 10 the 3D topographical face recognition.
Mm-hmm.
Most of the mechanisms that it seems like is talking about it, face, voice, iris, and fingerprint, I guess.
Mm-hmm.
When and how do you decide to start articulating additional kinds and sort of measurement strategies on these other modalities that might emerge?
It's really a data-driven problem, because you have to be able to test large enough databases to be able to figure out if it's even something worth fielding. If you can't test an error rate with, let's say, to 1 in 1,000, for example, is that really even going to be useful to anyone who might be relying on that data? So when you look at other modalities, the data doesn't exist like it does. Like, we've benefited a lot from the prison system, for example, because we have faces and fingerprints. But if you don't have that kind of data, you have to collect it, and that's expensive.
So one of the points you brought out very well is that
One of the points that you brought out was that all biometrics are not created equal. And so today in FIDO, there's a negotiation of authenticators, so to speak. Do you ever envision, per kind of the NIST 863, that we may have a negotiation of levels of assurance where you can have, any of N authenticators that meet that LOA?
Right. You mean outside of biometrics?
No, within biometrics.
Within biometrics, yeah. But they'd all have to pass some level of false match rate performance testing. And they'd also need to look at the spoof testing. That's actually, I shouldn't say they have to. That's what I've posited in the group. It's to be determined. Is that helpful?
I'll ask
Follow
afterward.
up.
Yeah.
Okay. Yes.
in the SOFA formula, you mentioned effort.
Mm-hmm.
How do you quantify that, or how do you measure?
Yeah, we are trying to figure this out. We don't have a good answer. So it's going to be some method of taking computational complexity between doing permutations of a PIN or a crypto key versus the computational complexity of a biometric algorithm. And it's going to be the time to make an artifact. The time to do permutations of a crypto key is nothing, right? It's also going to be the resources available, because, for example, to hold up a picture of somebody is very cheap, but to create a mask is, I think, like $800 to $1,000 to try to spoof anyone's face and order some rubberized version of De Niro or something. And but that's actually not that expensive if you think of it. If you want to attack somebody's bank account, $800 or $1,000 to create a spoof is not that much. But all those different factors we think will be part of effort, and we actually would love to hear from people on how they think we should do that.
Would you factor into that effort things such as breaches leaking biometric information, such as what we see, with social security numbers, date of birth, and other things that have been used for authentication or proofing?
We would not factored into the part that we're quantifying, but factored in the sense of there's some baseline table stakes cybersecurity practices that need to be taken, like encrypting data at rest, protecting data in transit. Those wouldn't be things that we would say you have to do a little bit or not at all. You have to do certain things.
Yeah, because I don't know if they exist yet, but I assume that one day we will be able to purchase fingerprints of people in the dark web.
Right, yeah. Right.
You can already do it, right? OPM leaked 6 million fingerprints.
Right.
OPM linked, 6 million fingerprints already. That's already an established problem. The question is whether or not you can actually use them to present effectively back against the biometric. I have either minutia or actual images of your fingerprint. Can I use that in an effective way that's going to bypass the sensor? Does it have all the data necessary?
On that point, so I attended the 863 presentation by NIST, and I was really surprised, shocked, I don't know if I want to say appalled, but that they're actually building in support for remote using biometrics across the wire and serving them on the server, which goes against the best practice of biometrics don't leave the device. So I was just wondering if you could comment on the fact that they kind of said we're having to accept the fact that it's done anyway, and we're trying to, it seems kind of like giving in to a bad practice. I just wonder if you could comment on that.
I think if whatever's in that draft at this point is considered a trial balloon, and if you think that's too far to have centralized databases of biometrics and rely on the security rely on mutual authentication for protecting that data, you should put a comment in.
I have one question.
Yep.
Right now, if the password is breached, then we say that change the password. If the same thing happened with the biometrics, then we can't change the finger or we can't change the heart.
Plastic surgery. No. Yeah, so in the draft for 63, for example, we do not allow the biometric data to be used alone. It always has to be with some other factor that is easier to revoke. That said, there are methods called template protection, revocable biometrics that can be used to revoke the pattern, but if someone can create a spoof, it's about good spoof detection, it's about protecting the data, it's about keeping biometrics combined with another factor. Any other questions? One thing I didn't mention is if you're not using presentation attack detection, but you know the device can be, you're going to notice that whatever is using biometrics is stolen pretty quickly, like your phone, and you can wipe the phone. That's a different way of dealing with the spoof issue. I don't think it's a long-term strategy, but just want to mention that because that strategy right now does not make me worry too much about the instantiations you see of biometrics now.
So maybe to the gentleman's question about, you can't erase your face, you can't remove your fingerprints, or maybe you don't want to without a lot of excruciating pain. This is one of the areas that I think as an industry, there has to be a lot more thinking about threat modeling and how you're choosing to apply biometrics. Absolutely a valid concern in the case where you're talking about governments collecting biometrics for border control cases and the like. In a consumer context, I think that's probably not going to be an acceptable solution. And that's why you have to look at other approaches where you're using something like FIDO, where you're using a biometric to unlock a cryptographic credential, because then, and this is an important piece, and it's something that people have to sort of digest a little bit, is you know, in the server-side approach, effectively the biometric is a password. It's a big, long, complex password, but you know, that's basically, it's a, you know, for a simplistic view, that's basically what it is. In the case of something using FIDO, you know, the biometric is essentially just a method to unlock that. It's similar to using a PIN to unlock a smart card. You could think of that. And so as a result, what are the attacks against that? Well, if I lift your fingerprint and I take a photo of your face, that doesn't actually get me anything because the cryptographic credential's on your device. And so really to be effective, I have to steal both the device and be able to bypass the biometric.
Right.
Still possible, you know, you may be a high net worth individual, a government official and the like that is subject to targeted attacks, which are very difficult to defend against. Nevertheless, the kinds of remote, scalable attacks that are harming all of us on the internet at large, you can actually significantly reduce. You know, as I always like to say, my friends from XKCD, you know, any of these systems ultimately suffer from the $5 wrench problem, right? Ultimately, if I really, really want to get access to whatever you have that you can authenticate to, I kidnap you, I throw you in a van, and I beat you with a $5 wrench until you get me access to it.
That's effort.
Any other questions? I had one question. The timelines on your studies and things that you mentioned, is there, and the drafts, is there a timeline around that? Maybe I missed it, but.
No, it's a good question. So we're working on a written draft to put out for the SOFA work. We don't have a date. I'm going to say off the cuff, probably end of the summer. But feel free to tell us what you think before then.
Do you have a logo for that SOFA initiative?
Would you like to draw one?
I think we could come up with one. It might be fun.
I had a joke about that, but it didn't go well the last time I told it, that we were going to call it Strength of Biometrics, but the email address sob@nist.gov was taken. So. It worked here.
All right, Elaine, thank you.
Thank you.